Hello, everyone. My name is Sneer Rozenfeld, and I'm the CEO of Cyber 2.0. I'm very happy and honored and delightful to have you guys here today, and I'm very happy to host this December webinar today. It's great seeing everyone. We have a very interesting webinar in front of us today. We're going to speak about cyber attacks. We're going to speak about recent cyber attacks that we've seen, and we're going to open them up. Before we begin, I would like to exchange my gratitudes for my VP Sales, Mrs. Yana Hefer. Thank you, dear Yana, for everything you did. She's been helping us setting out these webinars all over. And of course, the Chief Operation Officer in Cyber 2.0, Ms. Tanya Sarel. Thank you for everything you did. So let's get this show on the road. So hello everyone, we're going to speak today about the dangers of water. On our monthly webinar, we're going to explore a lot of interesting things today. We are very honored today because this webinar will be divided to three sections. In the first section, we are honored and we are very happy to have Mr. Daniel Lacker, the Senior Director of the Emergency Water Security Information and Cyber Division from the Government Authority for Water and Sewage. He will be joining us today and will be sharing his insight with us. At the second part, I will be exploring a bit about recent cyber attacks and how things are going. And of course, we will have the Chief Technology Officer of Cyber 2.0 giving us a technical overview about Cyber 2 OT, new solutions, new ideas, and new ways to protect critical infrastructures. So without any further ado, I'm very happy and honored to introduce Mr. Daniel Lacker, my dear friend. Daniel, take it from here.
Okay, thank you, Sneer, and thank you, everyone. Thank you for the opportunity. I'm glad that we have colleagues from abroad also on this webinar. I want to apologize because I put a presentation in Hebrew, and I didn't know the session is in English until half an hour ago, but it'll be only 2 slides in Hebrew. The other slides will be pictures and clips, so I think it's international and we can manage. I will load it up and we'll start. Okay, so I'll go into the business. First of all, my name is Danny. As Sneer said, I'm the head of the Water Security, Emergency, and Cybersecurity Division at Israel Water Authority. Israel is one of the countries that is very much attacked from cybersecurity issues in general, and specific only on the water facilities and corporations. So I must say that on a daily basis, on general daily basis, Israel water system is very stabilized. Although they are much on a daily basis as well being attacked, as you see in the news in the last year and even more. We have some missiles attacks from our neighbors from the south and the north. We sitting on the Syrian African reef, and we have the dangers of earthquake. But on a daily basis, we have cyber attacks against infrastructures in general, and specifically on water and sewage infrastructures. I would like to start a clip. Maybe you won't hear the sound. It doesn't that matter. But just a reminder how we all depend on a daily basis on cybersecurity issues, and specifically in water and sewage issues as well. So not everything has solutions with computer and cyber issues, but being serious, Israel water infrastructure suffered many cyber attacks. Specifically in 2021, we had a large cyber attack on big scales. More than 150 facilities in Israel were attacked with a footprint of Iran. I can talk about it because it was in the press and the news as well. I'm very proud to say that non-Israeli felt any disruptions in water supply or in sewage services, but we did have a large attack about many facilities. If you won't believe me, you can believe Fox News in this clip.
Fox News has learned that Iran is behind a cyber attack launched late last month against Israeli water infrastructure and that they used American servers to carry out the attack. We did reach out to the U.S. Department of Energy, responsible for U.S. cyber infrastructure. A senior official there reiterated the Trump administration's commitment to protecting America and its allies against these sorts of attacks. That senior official did not comment on the specifics of this story, calling it an ongoing investigation.
So until this war that we have right now in Israel, we suffer several cyber attacks. I think that one of the major things that we learn about cyber attacks, some of them are going to the OT system and trying to really affect the systems, but there's a lot of psychological attacks as well. I won't put this clip because it's in Arabic and it's translated to Hebrew, but eventually it's saying that we succeed to operate the water system in Israel, we can disrupt them, and nothing really occurred. And the clue, maybe I'll put it as well, even if you don't understand the language, I'm sure you understand and recognize the figures and understand the system. It was so-called attack. They weren't attacked, they were just pictured by cameras and put it in from a psychological film to make people in Israel panic on water system.
أنتمي إلى مدرسة تقول إنه الكذب ما بيخدم بالحرب النفسية. الصح والصدق هو اللي بيخدم بالحرب، هو اللي بيخدم بالحرب.
Cyber Avengers has targeted several Israel water treatment SCADA systems by cyber attacks.
So this is one of the examples. Even if you don't do a very sophisticated cyber attack, just hacking a few cameras, CCTV cameras, or even local cameras on roofs of houses, and take pictures of the right issues, you can create a psychological attack. And we're seeing more and more of those attacks on for structures in general, and also on water and sewage system. Now, in my state of mind, one of the major challenges or let's say attacks for the CEOs of let's say water corporations and other water facilities is people like Sneer. Although he's a good friend of mine, I think that sometimes advisors can create a total panic and can talk a language that CEOs cannot understand. For instance, if you see those very pretty girl and boy, by the way, the girl is my girl. But if you look at those, let's say, cybersecurity experts are coming to your facility, meeting with your CEO, and then tell them, we have a lot of challenges in cyber. You have to protect your OT systems, your IT systems, your CEO systems. Everything can be hacked. Eventually, your CEO will go into panic and he won't operate and he won't make good decisions. He'll just be in panic, and that will be his eventually operation system. He just put his head on the sand and won't deal with the problem. So I think one of the major things that we have to do on cybersecurity issues is to translate it to the decision maker on the right level, what to translate to him and bring him to get the right decisions, and not only attacking him with all the threats and all the hazards that we have all around. I'll give you two examples for a human behavior that CEOs can make sure that the operation will act according to them, and that might create good defense, not from the cybersecurity issues, but if every one of us is driving with his car to his work on a daily basis, you can make all kinds of courses how to avoid the cars accident and so on, but that will create a solution to the 5% of the extreme situation. But if you'll put your seatbelt and you'll make sure that your car is running smoothly and your tires are fine, you probably will prevent 95% of the car accidents, meaning that sometimes it's the behavior, not only the technology. So goes to the COVID-19, if you recall that we have this kind of a disease a few years ago. So if you get put mask and get the vaccine, you'll prevent 95% of the events and you don't have to go to the hospital. So goes to the cybersecurity. This slide I'll have to translate, but this is a sign I saw on a door when I came to visit one of my friends, and it says, in general, it says, dear the residents, because of maybe breakout in this neighborhood, we changed the code to the lobby. The new code is 1948, and now thank you, this is the house. So I mean, sometimes I see it also on cybersecurity issues. Everything is being detected and even protected, but then you see some note on the computer says my password is Danny 1996, meaning that sometimes it's the mainly behavior that protect us on 95% of the issues. For instance, another thing, this comes from the physical security issues, but this looks like a very good gate, but it doesn't do anything. It doesn't stop anything if you're not operating it right. So Israel Water Authority has a lot of regulation, has a lot of papers how to operate, but my way of thinking saying that you have to work on cybersecurity issues not as a project, but as an ongoing system that you have to take care of. You have to make planning and preparing. You have to do cybersecurity and assets. You have to choose sometimes between options. Sometimes it comes from economical side, sometimes from a dangerous side. And you have to make it on a daily, or not on a daily, on a yearly plan, ongoing plan that you have to check every few months and make sure that you are preparing again, because it's an ongoing system. It's not a one product that you protect the organization and you finish your hazards. Israel Water Authority opened a SOC, a Security Operations Center, in the Cybersecurity Bureau. We are connecting today all desalination plants in Israel 24/7 to our SOC. Most of the water corporation in Israel are now being connected or connected already to this SOC. And we can, as Israel Water Authority, can see a whole picture and provide a very good service to water corporations if we see any change or any hazards coming from those systems. But eventually, and I will stop with those two slides, I think that we have also to think about 0-day. I have a story about my son, which is today is working in a high-tech company. In the past, he was stuck with his car, and he called me, he says, Father, my car won't work. So I told him, I put some jumpers in the car, take the cable, jumpers, find the battery, and operate the car. It's not that he didn't know how to do it or he didn't find a battery. It doesn't in his iPhone, he can't see it in his iPhone, so he don't know how to operate it. Meaning that today, also employees and engineers in the water systems do not know how to operate manually the systems. And one of the challenges is, although all the cyber protection that we are doing, we have to make sure that this generation cannot operate manually, and we have to take cybersecurity very effectively and very crucial. So eventually, what I think is that we have to be aware of cybersecurity issues. It's a threat like missiles, like cyber, like other attacks. I think that in the following years, more and more cybersecurity issues will be on our table. I think that at least in Israel, our enemies will work more and more on cybersecurity as an opportunity. But I'm sure that we will be protected with the wonderful people that here on the webinar and wonderful companies like Sneer company. Thank you for Cyber 2 and have a good day.
Thank you very much, Danny, for that insightful presentation. Okay, let's move on to the next part. You spoke about various interesting things, which I'm going to explore. We're going to speak about cyber avengers. We're going to speak about the way to protect critical assets and how to practice those things in the best way we can. All right, so let us take this to the next notch, and let us take this to the next company. So we're going to speak about protecting water companies. We're going to speak about water attacks. We're going to speak on various critical things, and let's move it to the next forward. I always say, and I always use the sentence, if you keep doing the same things, you will always get the same results. Now, this is very interesting, and we will show you how recent cyber attacks occurred doing the same old things they did like 5 years ago. Nothing new happened, no new attack. It's just the same old attacks, and they are reoccurring. But before we started, let's speak a little bit about so many cyber solutions out there. There are so many cyber solutions out there. There are many cyber companies out there, and every one of them is trying to give you the best solution for cyber protection. There are solutions that are doing EDR, MDR, XDR, monitoring, SOC, IPS, IDS, that I spoke about it. So many things, so many critical assets, so many things we want to protect, and sometimes we don't know which solution is the better one. And more than that, which is the main problem, if you take all of them together, you will still not be protected by 100%. And this is, we need to understand why is that. We need to understand the way we think. We need to understand the way hackers are thinking and how they are operating in various regions. Well, when Cyber 2.0 was formed, we thought about what is the problem. And the way we see it is very, very simple. In every given moment, in every company, a single computer might be penetrated by a malicious software. This happens on a daily basis in almost every company. It's not so hard to infect a single computer within the company. But the main damage of a cyber attack is not a single computer getting penetrated. The main damage of a cyber attack is once the malicious software starts spreading through the network, infecting other computers and other servers. Very much familiar to the COVID-19 incident, a single person who has the disease is not interesting. The main damage is once it starts infecting everyone. Now let's explore today's solution. When we started looking at today's solution, we saw that the commonly used solutions today are called EDR. And we are seeing EDR solutions starting to getting installed within OT systems and other interesting places. So when we started exploring recent solutions, we saw that they are based on EDR. EDR means endpoint detect and response. Basically, these are solutions that are based on detection prevention, and or as we know them, IPS, IDS, and so on. Now let's see what happens. On the detection level, what everyone is doing is, first of all, they're trying to detect and recognize every malicious software. And then they are trying to prevent them from spreading within the network. Now, everybody's using their own gimmicks. These guys are doing behavior analysis. These guys are doing deep pocket inspections. These guys are doing anomaly detection and so on, or behavior analysis and so on. Now, why do they fail? Why cannot they solve the problem if you take all of them together? All of them together have great solutions, great gimmicks, great patents, great technologies. But eventually it's detection and then prevention. You are completely relied on detection before you are trying to prevent anything. So if you fail the detection test, well, game is over. Now, let's see what happens in OT. In OT environments, it's even worse. Because if a single computer is getting penetrated, and probably it's the HMI or something like that, then everything else will be penetrated. So we need to bring something else, and we need to rethink the way we need to protect our assets. When we started exploring what we can do and how we can face those challenges, we thought about all those detection and prevention. On the IPS, on the detection level, we realized that we'll never be able to identify all malicious software. And somewhere, somehow, we will fail detecting a zero-day attack. So we are using zero trust technology. On the basic level of it, if I cannot detect you, first of all, I will block you. I will alert the customer, and then I will continue analyzing who you are. On the prevention level, we also saw that eventually, if somebody will get a single computer infected, he will be able to remove the Cyber 2.0 agent, the Cyber 2.0 application from the infected computer. We build our system in a way that even if you remove me from an infected computer, I continue protecting the network. Removing the Cyber 2.0 doesn't give you an edge. More than that, it will lock you out of the network. We are using chaos algorithm to do cyber defense. I will not explore the chaos algorithm with you today. The chaos algorithm is a bit complicated. We are happy and honored to have Professor Louis Stone from University of Melbourne from Australia, which is one of our advisory board members who is checking the chaos algorithm to authenticate. We are using authentic chaos algorithm. The main idea of chaos algorithm is basically it's an unpredictable system, and if you break anything, if you change anything in the system, everything will change accordingly. Now, Danny spoke about it, so let us explore that even more. At 2024, we saw that the year is almost over. We are now at December. And we saw a huge rise in various cyber attacks. Just today, I read about a huge American company that was attacked by Chinese hackers. Very interesting. Today I read about it. Very interesting. The attacks are getting more sophisticated, and we'll explore them because the Iron Souls, the situation in Israel, we saw that there was a significant rise in cyber incident. We saw that there was a huge rise in cyber incidents on a global scale. And of course, the ongoing conflict between Russia and Ukraine is adding to the system, and it's adding more and more attacks and cyber attacks that are occurring. And we must remember, every smart thing, every new device we are plugging into the network, a camera, an IoT device, a printer, all of them can be used by hackers. If they are not managed properly and if they are not secured and they have not managed in a proper way, then all of those things that are connected to the network, that are connecting and receiving data from within our network, can be a doorway, a backdoor to the hacker. And every small thing is, well, basically, it's a target for hackers. Now, hackers are using many, many forms of attack. We've seen them all in the last years. We saw smart attacks using known weaknesses. We saw brute forces. We saw multiple hackers combining together to do defense attacking scenarios together. For example, you're getting attacked from Iran, China, and Russia at the same time from various locations and from different IPs all over. And of course, there's a problem with the shadow IT. The weakest link in the chain in the IT section is the human factor. You cannot control our employees, and we'll speak about it later on in the presentation, what we can do to better safeguard our employees because people will make mistakes. Now, we must realize that we are living in a great area and AI is here. AI was born and it was launched at 2024, and everybody's using AI. They're using Claude, they're using ChatGPT, they're using Gemini, they're using various aspects of ChatGPT. Now, ChatGPT is amazing, and we haven't even started realizing or analyzing its capabilities and what it can do for us. Now, every day we see something brand new it can do, and it's doing movies for us. It can do human impersonation for us. It can do music for us. It can do a lot of interesting things. But we must understand that hackers are also seeing the AI and all the opportunities it is giving them. Now, think about it. Back in the day, like 5 years ago, when hacker wrote a virus, he had to sit down, write a virus. Then he had the virus ready, and then he had to start delivering it. Today, when he writes a virus, he gives it to the ChatGPT and he tells the virus, give me 100 variations of this virus. And now instead of getting one new zero-day attack, you get 100 new zero-day attack done by ChatGPT. Now there is AI mechanics for hackers called Fraud GPT or Worm GPT that is enabling hackers to do a lot of interesting things, such as increase the amount of viruses, increase the number of attacks that can be made, and deliver a whole new bunch of attacks made and devised by the AI. Eventually, it's a whole new world, and there's our brand new attacks coming out there. So let's explore a little bit about attacks that we recently saw. There was a lot of interesting attacks we saw coming from the US, and we'll explore them for a second. We saw that there was a big attack at the Arkansas city water treatment last September. Basically, almost 2.5 months ago, we saw that there was something very interesting. A cyber attack targeted water purification facility in Arkansas City. Basically, according to the reports, at least, it appears to have a ransomware attack that tried to close the water in the company, close the water, and it caused disruption in operational system. However, as Danny said, the city managed to switch the the purification facility to manual mode to ensure water to the residents, even though we saw that there was a lot of low pressure for a short time in various places, there was low pressure. Now think about it. Very, very easily, hackers can take us back 1,000 years ago where we have to go to the well and start pumping water. Now, look, what happened at the Arkansas City? Well, let's see what happened. Let's explore this attack a little bit because there was numerous things, but all of them are the same. First of all, the key vulnerability that we saw was easy no network segmentation. The IT, the OT, and the IoT are all sitting in the same network. Doing lateral movement, moving from an IT computer to a water pump or to an HMI, basically you go around and nothing can stop you from doing it. Unsecured HMI. The HMIs, people are afraid to touch it. The HMI is the main controlling the human interface computer that controls our OT division. But basically, no agent was installed over the HMI, expecting the HMI to protect himself. And this was very problematic. And of course, there was weak external access. We are getting supported by numerous vendors on a daily basis. We have vendors that are connecting to our organization, giving us support, helping us, assisting us, and so on. It's very, very interesting. But even if external vendors or local users use remote desktop or anything like that, they usually choose the basic passwords as they can do. A1, B2, C3, or something like that. Admin, we've seen all of them, and it is still happening. There was weak credentials, no enforcing of changing certificates or changing passwords was enforced. And this basically caused very easier for the hackers to be successful in penetrating the Arkansas water system, even though eventually, thank God, it was avoided when they moved to manual and they continued the water treatment going through to the residents. The second thing we saw was the liquepa. Now, Danny spoke about it and he mentioned it. These are cyber avengers. We had the cyber avengers coming in and they did a Liquepa Water Authority in the US. They had an attack and they encrypted their HMIs. Now, there is Unitronics. They are using Unitronics. Unitronics is a great company. They have a great product. But one of the older versions they used was found in a weakness, and as a backdoor, it could have been penetrated. Now, cyber avengers, once they knew that, once they identified that the Unitronics has an old version which is penetratable, they started using it and penetrating Unitronics devices all over the place. Now, how can we have stopped it? Should have we bought, I don't know, new defense systems, high firewalls? No. This is basically patching. And the basic patches, patching, critical patches and security update. This is what they had to do. And if they had done security critical patches or security update, this attack would have been avoided. No need for any sophisticated defense systems, and there was no need of any sophisticated cyber attack to occur. Now let's see who are cyber avengers. We need to understand our enemies in order for us to protect against them. Well, cyber avengers is an Iranian backed up group. They are also known as the Soldiers of Solomon. They are the Soldiers of Solomon. They are a group suspected in affiliation with Iran's Islamic Revolutionary Guard, active since 2020. They've been around for many years now, and they've claimed responsibility for various cyber attacks. They specialize in going over water companies. Even in their Twitter, they are saying that they have attacked numerous water companies. They use a lot of false positives. All those companies they state or claim to attack never happened, but it doesn't bother them to do it because it's a psychological world. Once somebody publishes that you've been hacked, that you've been attacked, now it's up to you. You're already under attack in this moment. Now you have to prove that you haven't been attacked. Everybody's asking you various information, the privacy regulations, the cyber directory. If you're a public company, all the stakeholders want to know what happened because just some hackers published that he might have hacked you, penetrated you, stole your information, and so on. And in the Aliquippa, we saw something very interesting. It was multiple attacking happening. Now, if we used to see a single attack, they're giving you a cyber attack, they're doing phishing or they're doing DDoS or they're doing anything. In here, they did multiple cyber attacks at the same time. For example, they had a phishing attack going on, sending malicious emails or fake website to the users. Now, we saw that they were using also vulnerabilities in the critical systems, checking and see if they can penetrate to there. They were also doing DDoS, and they were doing multiple cyber attacks at the same time, which enabled them eventually to get in and encrypt the Unitronics device. Now, again, Unitronics is a great system, but you have to do critical patches and security update in order for you to be protected. Now, as we've seen in those two attacks, there was nothing sophisticated about them. All those attacks occurred because the basics were out of that line. We didn't use the basics, and the basics is basically changing passwords, admin users, critical patches, and security updates. Now, the next attack is more interesting because I've been thinking about it in the last month. I'm very interested about it because I keep seeing it happening all the time. I've been thinking about it so many times because the weakest part in the link, the weakest part is the human factor. Now, like 5 years ago, everyone got an SMS telling them, you want a free iPhone. Now, everybody got those SMSs telling them, you want a free iPhone. You're entitled to a free iPhone. You're entitled to a free Galaxy. And eventually somebody clicked the message. Now, hackers got more sophisticated over the years. And now instead of giving you a free iPhone, they're giving you the job of your life. Hackers are targeting our employees, and they're telling them, hey, we saw your profile on LinkedIn, and we found you a leader, and we found you very interesting, and we would like to offer you a position as the president as the vice president, as the CEO, and so on. And they're offering you the dream of your life, and they're inviting you for a job interview. Now, every employee says, eventually somebody acknowledges my greatness. If somebody eventually sees how good I am, this is the job I want. And then they take it. They do the job interview. And it's very amazing because they're sending them a false video link to do a video interview. And then you come to the interview and you come very happy. And then the hacker comes up. The hacker sits in front of you in a video interview and he starts asking you. He's giving you a video interview. And this is amazing because during the video interview, well, the victim downloads and runs a malicious JavaScript, and then they get an installation of a malicious software called Beavertail, and it gives them a backdoor, and eventually through the interview, while he's interviewing you and telling you how good you are and how adequate you are, and you are the guy they were searching for their company, they're giving you a backdoor called Invisible Ferret. The interview then is over and he's telling you, you're amazing. Thank you so much for your time. We had a great time. We are still negotiating with other candidates, and we'll be back to you in a couple of days to tell you if you're on or off. And then the interview is over. Within a couple of days, you're getting an email telling you, I'm sorry, unfortunately, we didn't find you good enough for the position, but you are still our champion. We'll stay in touch in the future. And in 6 months, every data you have has been stolen from you by a hacker doing fake job offers. Now, the best thing I can offer you is this. Yes, we have our system, and we have systems that are able to identify those things and block them in real time, no problem. But eventually, we need to do more training for our employees. We need to take our employees and explain it to them. I even published an article about it in various newspapers to let people know that, come on, it's the same. You want a free iPhone, just it's been more sophisticated at this time from the SMS. See how much hackers have evolved. They're using new tools of attacks. They are working on psychologically. They're trying to get into our organization in every chance. But there's hope. There's something very interesting that I just read today, and it's very, very interesting. There is hope. DEF CON. You know DEF CON. DEF CON in the US is one of the biggest organizations about protecting. And we saw that volunteers in DEF CON dive into America's leaky water infrastructure and basically why that hackers are coming together to start stopping attacks that are happening on water companies. We saw 6 water companies already registered to this idea happening. And exactly what will happen? Well, a plan for hackers to help secure, white hat hackers, of course, to help secure America's critical infrastructure has kicked off with 6 US companies signing to the coders to kick the tires. They're going to check the codes, they're going to do vulnerability, risk assessment, penetration testing, show them where are their weaknesses. Volunteers will work with the techies and they will be matched with each water companies and spend time helping suppliers hardening their system against outside attacks. We all see that there is a lot of things going on, and the main idea in the US is basically, well, they want to strengthen because they already saw what happens when China, Russia, or Iran having a picky nose around critical assets in the US. And there's hope. People are trying to do things. Good people are coming together to start stopping a cyber attack, and it's very, very interesting. As you see, this I read it. This came just like on the 24th of November, like one week ago. Very, very interesting. Look it up. It's there's hope. There's people doing good stuff. But until all those things come together, we still need to bring a solution. We need to start assisting our customers. We need to start and block the critical attacks that are coming into our critical assets. Well, Cyber 2.0, and this is basically warming up for the next part of Erez, of the CTO. Cyber 2.0 is always sitting down and thinking about how we can prevent attack before they're even coming. We are using the chaos algorithm. Erez will explain to it about more, and about a single solution, one dashboard to protect your IT, OT, and IoT. People are moving forward. Technologies are moving forward. We understand that. We have new devices. We have AI. We have a lot of new things and a lot of innovation and a lot of new opportunities coming up. So we need to bring a single solution to help us protect our critical assets, no matter if it's Linux, Windows, or any other thing we have installed in our network. And we need to adopt zero trust. And this is what we're doing, and this is what we're trying to educate our customers. You need to start adopting zero trust mechanism. Basic of it. If you don't know what it is not supposed to go into the network. The same thing applies to a company. If somebody comes to the company, is not getting identified, it cannot go through the main gate. You keep doing the same things, you will always get the same results. Hackers are using and embracing new technologies all the time. They are trying everything they can do to penetrate our organizations. And I think we should start thinking differently, and we need to start embrace new technologies, test new technologies, do POCs, listen to other people. It's very, very important for us to move forward and to enable and to embrace other technologies. Thank you very much. I would like to take it from here and move it to the CTO of Cyber 2.0, Mr. Erez Kaplan. Erez, you take it from here.
Thank you very much, Sneer, for the introduction.
Important to add, we will be having time at the end for questions. You can write them down in the chat, or after Erez's presentation, we will open the mics and allow everyone to ask questions, and we will answer them. Thank you. Erez, take it from here.
Thank you for the lovely presentation, Sneer. I will deep dive into the technology with some exciting new features that we added, and the old and very reliable chaos technology which backing everything up. So Cyber 2.0. Let's explore this. Sneer had said it, and I will elaborate about a lot of things. The problem is, in the current arena, that we want to remove the hacker ability to attack. The problem is extremely simple. Hackers can target your equipment, target your environment, whether it is IT or OT, with constantly shifting and re-innovative attacks. They are now backed up by AI that helps them. They're backed up by us. They come from inside us. And when they write something, when they plot something, they know how we defend everything. So when they introduce something new to the system, that new something is designed to penetrate your defenses, state-of-the-art defenses and everything. And everything that we have, state-of-the-art antivirus, state-of-the-art EDR, using anomaly and behavior analysis will simply fail because there is something completely new. They don't know what it is. They can't identify its behavior. It's mimic normal behavior sometimes. And it will bypass really until someone will identify it or the thing will attack somewhere and then everyone will add it. And when they do, another attack and another attack. We are in a current state of chasing our own tails, and the hackers are always one step ahead of us because, as I said, they are coming from us. And that is a very problematic situation. We see the rise of hacking all the time. More and more hacks comes and join. And let's say that the scalability of the successful hack are increasing by a geometrical rate, and it's backed up by AI. And let's say the predicament are not good by all the cyber companies. That's why we decided when we developed Cyber 2.0 to do something completely different that will unbalance this equation. We want to effectively remove the hacker ability to attack, and we want to protect the device and the spread of cyber threats inside your network. The question is, how do we do it on zero threats without the need of identifying them? First of all, let's go over some of the known attacks. Although Sneer has done so, I will go over them quickly. We've got attack on water system, opening dams and flooding. We've got disruption of traffic light, damage to energy infrastructure, attack on atomic reactor, for example, or a very famous attack, and they lock the hotel's room doors. It happened more than once in several hotels, and that's a problem because the people who are getting attacked are under stress to pay. They don't have enough time to remediate. The guests are locked in the room, so it's a very potent and powerful attack. So as I said, EDR is not enough. The main problem with EDR is the detection phase. We can detect everything. There is no plausible way that we can detect everything because there are always the unknown, things that come under the radar, things that we don't even know that they are there. So if we don't know it is there, we cannot prevent the attack. It is extremely problematic. You don't have 100% detection rate. You don't have 100% prevention rate. It's a simple fact. It's a funny thing. Even if you have 99.9 detection rate, the 0.1 attack that bypasses your defenses is enough to do all the damage in the world. Think of it. You have 1,000 or 10,000 attacks per day. One of them is enough to pass, and one of them is 0.001 or something like that percent. And that's what's happening, sadly. So no 100%, no 100 detection rate, no 100 prevention rate. Cyber 2.0 want to reverse this simple scenario. We don't rely on detection in order to do prevention. We have a very powerful detection. Our detection detects at the same rate and status as other detection system. When they identify it, we will identify it. But as I said, there is no 100% detection. We do not rely on the detection. Our prevention methodology, which I will explain further in a few slides, completely prevents the attacks before they are happening without us having the need of detecting them first. Sounds impossible, but that's what we are doing, and let's see how we are doing it. Just to mention, it's a double zero trust technology, and we are using chaos-based algorithm for that. I will mention briefly the hacker challenge that we did. We did 4 of them in Israel, in the United States, and over the internet, with a price of $100,000. No one was able to bypass our system. 6 hours all the time to prepare in the world. It was aired in Israel TV and in the United States. Extremely potent and powerful. It's a proof that we trust our system so much that we let hackers test it with a very, very generous price. They failed. Everyone failed during the test, and it was good testing to see the capability of Israelis and US hackers, and then over the world from Europe and Japan. Before I will delve into the chaos technology, I want to delve into the methodology. In the IT, things are a bit different. In the IT, we stop the spread of cyber attack. In the OT, we want to prevent the controllers, the PLC devices, from being attacked completely. But before we are doing so, we are using double zero trust mechanism based on our chaos. So in the IT, there is a methodology. We need to mark the files to see, to check, to verify. In the OT environment, there are extremely very few files that need to be marked. Sometimes between 1 to 5, can be 20 or 30 in several OT environments, and they don't change. So to impose our system in OT environment is extremely easy. There is almost no fuss at all. I will explain about the methodology, how we select files, because it has a very different value, but the point of it, we create a list, and that list marks everything that is allowed to bypass from the HMI for the controller, or if you have any other files or application. And what is happening is extremely simple. You have an infected computer. In this scenario, it is our HMI, and you have a controller. In between them, we introduce what we called a vortex gateway. A vortex gateway can be as small as my cell phone, if you can see the image. It can be smaller even, and it can be large depending on what it does. The vortex gateway, as it says, as its name stands, it's a bridge device. It needs no changes in the environment whatsoever, no changes in the network, no changes in any of the HMI or the PLC or controller device that it protects. It's completely transparent. It was designed to give protection to devices that we cannot install, change, or do anything on them, whether they are legacy device, Linux-based device, or just device that no one knows what's inside. From cameras to PLC controllers to refrigerators to lights to doors, everything that you can imagine, which is OT or IoT based, the Vortex can extend its defenses to. And what is happening is as follows. There is a trust list that we discussed about it, and I will show you how we achieve it. And when something on the trust list wants to move forward, if it's verified that it is on our trust list, we take the port number that it is using, in this scenario, port number 80, and using chaos and time-based algorithm, we change the port number into something completely different. We change it every second. In this scenario, 80 has turned into 10,000. Once it passes the vortex gateway, which is a bridge, everything gets descrambled. So 80, who turned into 10,000, revert back into 80. Both the HMI and the controller speak and communicate in the original port. They are unaware that something has changed in between. From their perspective, they communicate normally. But when an unauthorized, unwanted, unknown, malicious application wants to do precisely the same thing, want to communicate from the infected computer with the controller, and she wants to do it in the same port, which is supposed to be open, we are doing nothing. We are allowing it to go over the network with the original port. But once it bypasses the vortex, everything that passes the vortex gets descrambled. So 80, who remained at 80, turned into a garbage port and get discarded by the other side because he doesn't understand what he is saying. It's coming in a port that no one is listening to. And it's important to emphasize that both the 10,000 and the 4,800 in this scenario changes every second. Now let's explore why this simple scenario is so powerful at mitigating cyber threats. We've got multiple types of attack. Direct attack, attacking the protected device from authorized computers, adding yourself to the trust list, or piggybacking. Let's see what happened. An unauthorized device. It can be one of many things. For example, we call it the Chinese chip attack. There is something embedded on the HMI computer hardware directly. Happens before, happens again, happens right now all the time. It can be part of the motherboard. It can be something on the PLC itself. It can be part of the mouse that you connected to the computer, which you bought from some unauthorized seller or from authorized seller. Thing like that happened even to motherboard of Asus, which was a major recall. Thing like that happened in very famous cyber attacks like what we did to Iran and the core. Another thing is to connect a device to your network, to connect an unauthorized device, jump over the fence, connect something to the network. This is a closed OT environment. No one will scan the network continuously to detect it. And even if you do, because you have an EDR and XDR, OT people usually don't look at these readings. And once you connect an unauthorized device, whether it is on the hardware or on the network, you can start scanning the network. The PLC will not shut down if you will get the wrong password. You can start identifying the communication, the traffic, the protocol, identify the password maybe when you capture it, and attack the controller directly. If you have a device on the network, you can do whatever you want. You can shut down the network with DOS attacks or DDoS attacks, depending how many devices. You can guess the password, hack the password, brute force the password, and start giving command to the PLC directly. Basically, you can do whatever you want. But if Cyber 2.0 is introduced and there is a Vortex gateway in front of the device, every command, every attempt, every scan, every DOS attack that you will make will go through the Vortex, and everything will get changed along the way, and every one of these attacks will fail. Even a massive DDoS attack that bypass the Vortex will simply drop because the half of the attack is the response. There will be no response, and the network will be much clearer. So attack that try to disable, to take control, to give false command using an unauthorized device will fail. Then we have something infecting the computer. This is the most speak about attack in most of all the regulation. This is what we try to protect about when we install the OT defense system. This is a supply chain attack. You have an air gap environment, but once in a while, someone comes to do something to the computer. Maybe it's an engineer, maybe it's an update, an upgrade, a change, a shift. Another computer is connected in order to do something. And on that computer, someone has installed an infection, and that infection is designed to step toward the HMI computer. And once it does, it sits there and directly attack your PLC environment, your OT environment, your SCADA environment. And it's a problem because EDR and XDR solutions are designed to work with signature or behavior analysis. You cannot do a behavior analysis to a virus that acts precisely as your HMI software. And since no one knows what it is, the signature base will fail. And since a lot of time you have software that are designed to know whether the wrong measurement is sent to the PLC device, but the virus will make sure that your software, the PLC, will not the PLC, the HMI will send the normal result while the PLC on the other side get the hacked result. It happens in several locations, and stuff get hacked along the way without anyone realizing it until it's too late. If Cyber 2 sits there, only authorized application can speak with the other side. No matter what type of application, no matter if that application knows the username and password of the other side and speak with the correct protocol, once it passes the OT gateway, it will get disabled in the wrong way and will not be able to communicate with nothing, while the normal HMI traffic from the HMI, from the authorized software, will be able to speak flawlessly. It means that in order to hack our system, you physically need to go to the HMI computer, and that's not a hack because that's the only thing that will work. Another thing that we introduce is even in the case of more problematic attacks. We spoke about supply chain attack. There are two types of supply chain attacks. If the attackers know what defense measure you have, and a lot of time countries and large criminal organizations do their homework, they can do something, plan something using supply chain attack that will change something in the defense. For example, we are using a whitelist. They can add themselves to the trust list. They can add themselves to the firewall, change the antivirus, change something in the defense measure that will allow them to bypass freely and do whatever they want, and your defense measure will tell you that everything is okay, because that is what they have been designed to do. But Cyber 2.0, not free from reverse engineering, though, it is a chaos-based platform and was designed to protect itself. It's true that you can kill the agent because you have local administrative privileges, kill commands, memory manipulation, and the list goes on. It's true that you can try to change the structure and add yourself to the local trust list on that specific computer. We cannot prevent you. This is computer, this is how it works. But as I said, we are a chaos-based platform. Change this parameter in a single computer, and you destabilize the algorithm. The algorithm uses precisely these things in order to create the scramble ports. Change the scramble ports on one computer, all the other computer, without even aware that you are doing so, will automatically block you in the first second. It means that no matter what you will do, what you will change, what you will add, that specific HMI will be locked from doing anything to the network, while everything else will work freely. It's true that this attack will shut down the HMI, but if someone has gone to this length to do something, this is precisely what you want to achieve, to shut down the HMI before any damage will be done, because this is a very problematic and dangerous attack. It is also emphasized the double zero trust that we are incurring. Only authorized device with authorized software can communicate over the network. Authorized device without the software and non-authorized device with the correct software will fail. So it's a double zero trust implication. Now let's go to the next step. Then we have another sophisticated attack that do the following. It sits on the HMI computer, but it's not speaking directly with the controller. Instead, it's giving commands to the HMI software to do stuff for her. In theory, that will allow her to bypass, again, regular XDR and EDR, because it's a step designed to bypass anomaly detection. And in this scenario, we even added a PowerShell, that she's using a PowerShell which is authorized to give command to the HMI, so it will be even more undetectable. But Cyber 2.0 is another layer of protection besides just the chaos mechanism, the one that allows us to create the fast list initially. We call it the reverse tracking mechanism. The reverse tracking mechanism does as follows, which has very strict implication for many things. Every process that loads into the memory process or sub-process is being recorded. What is being recorded beside the process name and various information is also the hash of that process, the hash, the MD5, the SHA, the signature. We create them on the fly. And another thing that we are doing is marking the connection between the processes as they happen. And we don't care how they happen. We don't care it was inter-process communication, out-of-band injection, file system access, memory manipulation, everything works. We simply mark that process 1 did something to process 2, then to process 2 to 3, then to 4, and then 4 went out into the network, leaving the boundary of the computer. But if one of this chain was not authorized in our trust list, the entire chain will break and will not be allowed to go over the internet, while the normal chain will go out normally. So our malicious chain that target the HMI component will fail, and the normal HMI activity will work flawlessly. Now, this thing has extreme value besides just the cyber defenses. It creates an active inventory of everything that was ever active in the HMI or the protected computers. And it does so from the moment Cyber 2.0 was installed. So you can go every time to the system and see what process and what application were installed on your premise and when they were first detected. It also creates the hashes, allow you to better give value for your cyber personnel, because if the inventory was good for your IT, then the hashes that are stored indefinitely are good for your cyber personnel, because if you got hacked by a specific unknown, let's say, malicious software, and suddenly the cyber authority send you an urgent list to check and verify, you will go to our software, you will check, you will put the identification name or hash in our system, and it will immediately show you on which computer it was present, when it was introduced to that computer, and it was also blocked because no one added to the trust list. Very, very effective. And the third thing, the third benefit from it all is regulation. The database is structured in a specific way, and the information on it stays indefinitely. And that information and that database is vital to mark a lot of V's toward being compliant in multiple regulations, from 27001 to HIPAA to PCI to regulation required by NIST, by privacy regulation. A lot of the most problematic compliances are being set in this specific database. You know what was installed, when it was installed, and it stays indefinitely, which is very, very important. Now, to add to this, we added a new system, a brand new feature that we have added into our cybersecurity software, which is a unique alerting system that alerts you from unauthorized internet connection. What does unauthorized internet connection means? There are several ways. For example, a computer in a closed network is not supposed to communicate with the internet. But if such a computer communicates because someone connected onto an unauthorized device and is controlling it, it's a problem. You need to know it, and that computer can connect. Sometimes there can be a human error, unintended connection, especially when you connect a router or a computer that has a bridge or something. You accidentally create a network connection. And a lot of time you have computers that are designed for maintenance that interact with your current network, and they can create a breach, an intentional breach toward the internet. And sometimes this computer does not supposed to connect to the internet at all, but when moved into another environment by mistake, they can connect to the internet when connected to a wrong environment. Any of these scenarios are extremely problematic in OT environment and need to be immediately notified and identified. And our system does the following. Every time that an unauthorized computer is detected being connected to the network, remember this is an air gap environment, the agent automatically shifts and connects to our cloud server, and our cloud server automatically sends a warning, an email, an immediately email to whom everyone is registered to hear it, saying that this computer is now connected to the internet. That thing alone can save a lot of troubles, a lot of times for any of these scenarios and more. But furthermore, we are also doing the following. We have additional capability for this system. We not just send a notification about the unauthorized connection, we also monitor all the connection. Once this computer is connected to the cloud, every communication that it did over the internet is automatically being stored. Every network flow, any address that it is used, any user that uses it, any program that connected it, any port that it used in order to do the connection and more is stored in order to later be analyzed if you want. And if that is not enough, the operators, which is you, can send a command to lock it remotely. So it's connected to the internet. Until it was connected, everything was harvested. You can send a command and the computer will be locked. Any connection to the internet and any other network will be blocked until you will release it again. These are extremely powerful and potent tools that allow even information from within an air-gapped environment, because the agent shifts its focus from the local server automatically to the cloud server, send a notification when it was connected to the internet and the information is being harvested and analyzed, which spare the need the later try to find within the local, let's say, events of the computer, which are usually raised by the hacker, to know precisely what he did, where he did it, identify the hack, the target, and the attacker. something that we need to emphasize. Critical mostly in IT, but sometimes it's also important in IT and IoT, especially in medical devices. Our solution is fully compliant with GDPR because we do not read the data. For example, if someone has opened a Word document relevant to IT, but in IoT and OT you have the same thing, we will know everything about it, who opened it, which user, source, destination, computer, which application, when it sits over the network, everything, but we don't read the data. The same goes for HMI device that sends information, we don't read the data inside. But if for some reason that data drop a payload, we will intervene. If someone tries to manipulate the data, we will intervene. So we fully comply with privacy regulation, and in the other side, we fully help you to comply with this regulation if required by your own regulation. How do we deploy the Vortex devices? As I showed you, the Vortex devices are bridge, and they can be deployed in many ways, but basically they are a simple bridge with 2 Ethernet cards, can come with 4, can come with 8 as well if required. But as a bridge, they can be deployed as one-to-one, as one-to-many. In this scenario, you can see that a single Vortex can protect multiple OT devices, scenario which is very common. And here, for example, you can see that each controller has its own unique OT gateway, its own unique Vortex devices. Of course, the solution can be mixed. For example, a water facility have multiple wells across the town. Each town has its own unique Vortex gateway to defend against the controller there. Another factory, for example, has all the devices connected into a single switch, and that switch will be protected by a single Vortex entity. And so on and so forth, and you can mix between them. So this is how to easily deploy the Vortex gateway. And as I mentioned, they can be small. If they are protecting, something like this can protect up to 50 normal controllers. Of course, if it's protect multiple Linux server, then you need something much, much larger. That concludes my demonstration. If you have any question, now is the time.
Thank you, dear Erez, for that lovely presentation. If anybody needs to ask Erez anything, or Danny, or me, we'll be happy to answer any questions you might have. Let's see if something is in the chat. Nothing in the chat. All right.
Let's open mics.
All right, last opportunity before we wrap it up today.
Sneer, maybe we'll open mics, and even if everyone wants to ask verbally and not through the chat.
Everybody can open their own mics. I've given them permission, so everybody can open their own mics and ask away whatever they need to.
Okay.
It's open.
תודה רבה.
Well,
מאוד כמו תמיד.
תודה, שניר.